Hello everybody, and welcome to part 2 of exercise 1. We're still looking at page 15 of the workbook. And just to remind you of the instructions here, they're giving us a vector space, V, which in this case is the set of 2 by 2 matrices, and they're asking us whether or not this subset W is a subspace of V. Okay, so as we think about this, let's first think about what the set W is. So it's the set of 2 by 2 matrices that have this form. So we have to have zeros in these two positions, and then notice that the entry in the lower right-hand corner has to be the square of the entry up here. And that number A can be anything. Okay, so is this a subspace? Well, it turns out that it isn't, okay? And to prove that it's not a subspace, often a good strategy is to go back to theorem 1.3 and just to try to show that one of the three properties in theorem 1.3 is not satisfied. Okay, so I'd like to demonstrate to you, in this case, that closure under scalar multiplication is not satisfied. Okay, and there may be other ways to show that this is not a subspace, but that's just one way. Okay, so here's how this argument might go. We'll start by choosing some non-zero value of A. I'm just going to choose A equals 2. And notice that if we do that, just kind of go up to this general form and substitute 2 in for our A's, we get 2, 0, 0, 4. That has to be in W. It fits the form of what it means for a matrix to be in W. Notice that 4 is the square of 2. That's basically what makes this work. Okay, however, what would happen if we took that matrix that we just came up with and multiplied by a scalar? Okay, I'm just going to multiply by the scalar 2. Well, if we do that, we're going to get, let's see, 4008. And then, what do you think? Is that matrix 4008 in W? It isn't because of the fact that 8 is not the square of 4. It doesn't fit the form up here. Okay, and we'll just mention that in words because of the fact that 8 is not equal to 4 squared. So what have we just shown here? Well, we started with a matrix that's in W, and we demonstrated that if we take a scalar multiple of that matrix, it's not in W. Okay, so this set is not closed under scalar multiplication, and therefore it can't be a subspace. Okay, so let's put that into words. Okay, so we're done with the problem, but maybe just one comment, okay, to go on the end of this. I want you to notice here that we used a specific counterexample here. Okay, we didn't try to give a general proof here. Okay, so we want to disprove a general statement, so all we really needed was one specific example, 2004. That worked, and so we used it. It gave a nice kind of compact proof that this is not a subspace.